Today, I'm going to do a walkthrough of an Excel esports competition. This case is titled Pipemare. It's from round 8 of the Road to Las Vegas in 2025 of the MEWC, the Microsoft Excel World Championships. The case was written by Juan Cifuentes, Excel man, who is also just starting a Chilean FMWC branch. Very exciting times. This case has us walking through a grid of pipes and making sure that the connections flows or doesn't flow, identifying where it works and where it doesn't. Let's get started. And we're off. Let's go. Okay, so we are doing pipe maze. We've got this table here, which will name T connects to or from some binary numbers. So here, this is a conditional lookup. So we're going to look up pipes, and then the return column depends on what they give over here. So if the right letter equals M, return from, otherwise return to, and then just concat all that. Okay. For this next one, we want to see how many connect in a particular direction. Okay, so we'll start off with the same base logic of the conditional lookup. And from here, we will deconcatenate each of those. Let's map this. Map. And then we'll deconcatenate each of those and multiply by the deconcat of the direction that they want. Let's get you that over here. And then what? We have to sum those results. So that gives you a connection for each one, and then just wants to know how many times. Okay. Will it flow? So this is just looking for the right, if the right connects to the left. So we'll say equals X lookup the 2 on this pipe. Just the right value. See if this equals 1 or not. Versus the from for this one. And if both of those are true, then yes, otherwise no. Okay. All right. Can you connect these without rotating them, but you can move them? Okay, so we're gonna say yes. Similar thing I want. The 2 and the from. And then we're going to check verticals and horizontals. Okay, so we'll say deconcat, we'll check the left 2, which would be up and down, times deconcat left of this. And if either of these are true, so we'll just sum this up. Greater than 0. Okay, so that is vertical, and then to do horizontal, we'll take the right 2 instead of the left 2. Gotta keep this. Okay, and then our final answer would be like ifs and that, then we'll return what? D. If neither one is true, then return no. If that's true, return vertical, otherwise horizontal. All right, good. This one wants to know if they connect, which ones don't connect in this string. So I'm gonna jump back up here for a sec and give myself a lambda to work with that we'll call connects. I'll mark these first two cells as my inputs using OA robot. And with those marked, I can say equals, let's see, just if either one of these is true, vertical or horizontal, and true, and then use OA robot to say save lambda. And we've already marked our parameters. So now we have a lambda that says connects pipe 1, pipe 2, and it'll return true or false. So that helps right here where I can say map the first 9 pipes and then the last 9 pipes. And we can say connects, so each pair gives an array of true and falses. We want to filter, we want the ones that don't connect, and then show the positions here. So it's going to be 2 through 10 on the filter, and then concatenate the results. 2, 4, 6. Okay. Okay, so far so good. Okay, this one has a sequence of pipes, and we have to find where the connections breaks. But this is different because you have to track the inflow and outflow. So let's do a data table. So equals dconcat, and then xlookup these, returning the 2, and returning the from. Okay, now we want to say connects via. So what does it connect by? Well, equals, let's see, dconcat on the from here times dconcat on the 2 gives you the place where it actually connects from. Oops, I don't know why I did that. Concat. Okay, so it connects via, and then you have to track the outlet. So the problem is going from and to, you have to swap the first 2 digits and the last 2 digits. So I'll just call this swap to convert this connects via, because I want to be able to compare the connects via to the next one that we're going to use. Instead of the from, I want to use the 2. So we'll say equals mid to 1 and left and right and mid 3, 1. All right, so that's a swapped set of values that I can now say the outlet is going to be dconcat that times dconcat this. No, that's not right. We want it to be, so this connects here from the going downwards or up on this value. We want it to be returning right. So actually, instead of Let's start this over. Equals deconcat. So here's your swap. We want to actually filter this on the opposite values. So now we'll multiply by our deconcat. And then concatenate these together. Okay, so that's our outlet. It returns the water flows from this pipe down into this, and then it should flow outwards to the right, catching this on the left. And so now, instead of connecting via the two, it's going to connect via the outlet. And then the rest is the same. Okay, and then from here, we'll say we want to find the first place where there is no outlet available. There's no match from here. Yep. Okay, so in this one, we have to start at a source and find out where it ends. So we'll do the same thing, create a data table. This time we have an address to work with. So we're going to be working with this map over here. Oops. Name this map, and we'll create a little table so that we can do address references. Just like that. And I'm copy pasting values, turning this into a table so that I can do easy structured references. And we'll just join this on the pipe value, tpipe t2. Do the same thing for from. All right, now we're good to go over here. So we'll say x lookup this. Oh, I didn't name the table. I did name the table. Okay. So x lookup m address. No, x lookup this. And then returning. What do I want to return? Let's return the pipe. And then we'll return 2. And then we'll return from. So 2 from pipe address. Okay. So then the next one, it's going to follow basically the same outlines here. Connects from via swap outlet. Only we need to know the outlet is, the starting outlet is this. And then the next address over is going to use this outlet. Okay, so we're going to say address, the last row number, and then we're going to subtract if the first value of your outlet equals 1, or add if the middle, if the second value equals 1. That's your row. Column be this minus, let's see, the mid, let's see, the third character equals 1, or add if the last character equals 1. So that's our next address. These guys are the same. And something's wrong there. So Q5. Okay, so we don't have an outlet here, but we should. We should have an outlet. So let's see what we need to do. We concat. We should connect from to and from. Let's move this down. There we go. I want this to stop when it finds the valid endpoint. So let's say if that equals an anchored stopping point, then return error. Otherwise, give me that value. Okay. And then what we want to do is equals count if my pipes are equal to the value that they're asking for. And this all gave good values, but I'm concerned, I don't know how far out this went. This is not using dynamic arrays. So just as a test, I'm going to plug in my NA here and see if any of these are still going. The fact that these are all errors means that we've gone out for far enough and that I can trust these answers. So these are good. Okay, bonus questions. How many pipes are in the pipe maze excluding sources and outlets? So we have this table, comes in handy here. We can just filter these. And it says 1777. All right, for levels 1 and 2, how many times can a pipe connect to the right direction? Okay, so we'll say equals x lookup, all of these values, look up the pipe, look at the 2, and just take the rightmost value there, should be 1. So sum 52 for level 1, and slide this over, also 52 for level 2, for a total of 104. Okay, excluding the example, how many potential connections are there in level 4? So we go down to level 4, and it just wants to know how many connections there are. So we labeled these V, N, H, and D. And D corresponds to 2 connections. Vertical and horizontal are 1, or N is 0. So I'm just going to do a quick X lookup on our answers into this mini table that we just created. And sum this up is 17. Okay, how many pipes in pipe maze connect to at least one other pipe? So we've got this maze here, and it wants to know how many connect. That's actually kind of tricky. So let's do this. First, let's find out where each of these are pointing to. So if you start from like address C3, for example, you could potentially be looking up, down, left, or right. So my first thing I want to do is find out which addresses it connects to. So I'm going to start by saying hstack address, and we'll give the row number and the column number, and return type 4. So I want this times 4, up, down, left, and right, but we haven't changed them yet. They're just C3s. So to do up, it's going to be subtract 1 from the row, down. To do left is subtract 1 from the column, and right. So those are our addresses. Let's filter just the ones that this actually connects to the pipe shape. Okay, that didn't work. I think because this should equal 1. Okay, so there's our filtered addresses. Let's just do a text join and bring it over to our table. So there's the cell addresses that it connects to. I'll call them neighbors, or N. Then let's say we're going to, for each one of these, so let's say split. Let's map that. No, we don't need to map. We just X look up these values and address and look up their neighbors. So basically, we're going to look up the neighbors, and if the neighbors point back to this address here, then it connects. So we will map these values, lambda v, and we'll say is number find. We want to find the current address in each of these neighbor of neighbors. So that is giving false and false. That's good. So if either of these are true, it's a connection. And then we'll just make this an integer, with the total being 1504. Okay. All right. If you trace the path of the pipe sequences from level 7, including the example, they spell something. What is the full message? Okay. So in level 7, we have these paths, right? So I need to find a way to get all the addresses that we need to look at. So it's going to be a text join, and just a quick filter out of the errors. We'll use a to call, and then extend this data table. And lastly, we'll just do another join of all of these values to get all the addresses that we want to look at on this map. Okay, let me relocate this table. I want it out of the way. Okay, good. Now let's make column width the same here. Okay, so it's going to be equals if the address of the map is in this array, then we want to see the value. Otherwise, we want to see nothing. So that's going to be the logic here. So if is number x match, and then what we're going to do is build the addresses. So we'll substitute out $signs by after you're doing a map of the map. Lambda v, we're going to do cell address v. Then we'll substitute out the $signs, and then look that up in this array up here. And if it's there, return the map value. Otherwise, return blank. And so that gives us summa cum laude graduate. You could argue this kind of looks like an R, but I think based on context, this should be summa cum laude graduate. Good. We're missing something. 1074. I bet I screwed something up in the process here. Level 7. Yeah, what's going on with this? I think this is just a data table error. Yeah, it was. Okay, 1250. Sweet case. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.